I'm Avi Mukherjee. I have a background in scientific computing as a physicist, but currently I work as a software developer at ClusterVision. And I will tell you a little bit about our experiences in using Docker, OpenStack, and combining that with high-performance computing. Okay, so ClusterVision. What ClusterVision does is basically build high-performance computing clusters. Okay, so we get the hardware, we assemble the hardware, and we install the software on it, provide support. So we go all the way from the hardware to providing support. Most of our customers come from academia, mostly universities. We also have some customers from the industry, mostly automobile industries. I mean, that's sort of the customer profile. Now, one of the things that we have been hearing from our customers for the last few years or so is that they want to run their HPC applications in a cloud. In particular, with OpenStack, because it's by far the largest open source cloud solution that we have right now. So they want to run it on the cloud. And why do they want to do that? I mean, it really comes from two different perspectives. First, from the users. From the HPC users, what a cloud gives you is flexibility. In a traditional cluster, you are sort of bounded by what your sysadmin chooses for the environment. I mean, if the sysadmin says run CentOS 7, you have to run CentOS 7. You don't have an option. So that's the push from the user side, that they want more flexibility. They want to customize their own environment. On the other side, from the management perspective, from the general IT people, cloud is very good because it lets you manage everything very transparently. I mean, you have a dashboard from where you can manage all your resources at the same time. So these are the two main reasons why we had a lot of users saying that they want a cloud. Now, the most naive way of doing that is to just take your HPC applications and just move it to a cloud. I mean, a cloud by a cloud, what I mean is infrastructure as a service. It just means it just allows you to fire up virtual machines. Okay, that's what OpenStack does at a sort of core level. You fire up virtual machines, you can configure your networking around it, but that's basically it. And what you can do is you can just take your HPC applications, just push it to these virtual machines and hope everything works. So you try to do that. This is what we want to do, and you do that. What happens? That doesn't work. And the problem is, HPC applications are very special. I mean, they require a lot of support. They require InfiniBand, usually, if you're running a tightly coupled application. They require GPUs sometimes, they require compilers, they require libraries. It just doesn't work like that. What the users want, usually, is a platform which is fully functional, and they want a very thin layer of customizability on top of that. They don't want bare virtual machines. So if you just take your applications, try to push it to a cloud in some generic virtual machines, it's just not going to work. So we just go back to the drawing board. That didn't work. And then said, okay, what can we do? And as you can imagine, this is a Docker workshop. So the solution that we came up with is Docker. So you just run your HPC applications in Docker, in containers. What does it allow us to do? It allows us to provide a platform for your HPC applications. And then the thin layer of customizability that you want, that comes because the containers are customizable. So you don't need that full customizability that comes with virtual machines with additional overhead. And this is essentially what we call Trinity. This is our product. This is the project that I have been working on. It's an open source project. We have a GitHub repository. You can go look it up. So what we do with Trinity is that you have a cloud, and that cloud is OpenStack. Okay. Within that cloud, you have a plugin, which is the Trinity plugin. And if you are trying to do your cloudy stuff, the regular cloudy stuff, you want to run a web server, or an email server, or a VDI, or all this stuff, you can just do that. You can just fire up your virtual machines with a regular OpenStack dashboard. Nothing changes. However, if you want to run your HPC applications, then what you do is you just use a Trinity plugin, which is still there in the dashboard, And that really just allows you to run your applications in a container. Okay? And this whole thing happens in a multi-tenant environment. So, you don't need one tenant. I mean, you can have as many tenants as you want. What you get bare metal performance. This is something you would otherwise lose in a cloud. I mean, if you're just running virtual machines, you don't get bare metal performance. With containers, you get nearly bare metal performance. We provide the full stack, the HPC stack, which means the compilers, libraries. You get the full modules environment. I'll get to that in a second. And you have this thin layer of customizability. So if someone wants to still do something on top of our stack, they can do that with their containers. All right, so I think this slide, this particular figure, I mean, has been already discussed about this. This is the IBM benchmark that they did, comparing containers with bare metal performance and with virtual machines. And you see that with containers, you basically get the same performance as bare metal within statistical fluctuations. Okay? With KVMs, if you run a virtual machine, you take a huge performance hit. So this part is completely non-negotiable for HPC users. You cannot lose performance. We also ran our own benchmarks, and they basically tell the same story. I mean, we ran HPL, this is high performance linpack, stream, IMB, and really the result is the same. I mean, you don't lose performance with Docker, and you do lose performance with virtual machines. Okay, so how would it work in practice? If you want to, how does Trinity work? So suppose you are the principal investigator, you're the department lead or a head of a research group, and you want some new HPC resources. So you would come to your system administrator and say, hey, I need some HPC resources, give me an HPC cluster. And the sysadmin would then go to the dashboard and say, make cluster. And sort of, if I can bring it up, this is what the dashboard looks like. So you have, here I have allocated all the nodes, but typically you'll see your nodes as over here grouped by hardware types. So GPUs, generic nodes, fat nodes, whatnot. And here everything is allocated. This is a very small cluster with just 3 nodes. But here you'll be able to see which nodes are unallocated, which are allocated. Then you can come here. These are the lists of OpenStack tenants. It's a multi-tenant setup. So you can just choose whichever tenant you want to give resources to. So let's say in this case, let's suppose you wanted to give more resources to the demo tenant. Then this is what you do. You click on this edit cluster, and it'll bring up a menu like this. And then you can go and allocate the number of nodes you want to give to that particular tenant. Each of these nodes, these are compute nodes, and each of these nodes is running a Docker container. Okay? And that's what gives us the flexibility. I mean, you can just, if you want a different environment, you just fire up a different container in that node. Okay, so that's what the dashboard does. The sysadmin says, make cluster. Dashboard goes to the Trinity. The backend is powered by our API. So the dashboard sort of tells Trinity, the Trinity API, all right, fine, make cluster, allocate these resources. And then the resources are allocated. This is what it looks like in the beginning, before any resources are allocated. Okay, and this is the underlying layer. You have some sort of OpenStack nodes where you can run your virtual machines. So these are all virtual machines that are running on OpenStack nodes. And these are running, let's say, a web server or something like that. Then you have these compute resources. These are compute nodes which will run containers. And you also have these login nodes. I'll come to these login nodes in a second. The login nodes are also virtual machines, but they're a very special type of virtual machines. And the color coding here is by tenant. Each color represents a tenant. So all these gray nodes or the gray VMs, they belong to one tenant. The yellow ones belong to one tenant, and the red ones belong to a different tenant. Okay. So when you say make cluster, suddenly these unallocated, so the white ones were unallocated nodes. They didn't belong to anyone. They get allocated to the blue tenant. At the same time, behind the scenes, since you said make me a cluster needs a head node or a login node. A login node is also created. A login node in this case is a VM, and it's a little bit more secure because it's a VM. Okay, you get more security. Why is the login node special? It's special because it's running your the controller daemon for your scheduler. In our case, it's Slurm. All these nodes here, all the containers in these nodes are running the Slurm daemon. Okay, so they can accept jobs. It's a fully fledged. This is a fully fledged cluster. It's logically a regular HPC cluster running a scheduler. The login node runs the Slurm controller daemon. It also runs the authentication server and things like that. So you can have your own set of users and everything, and your job scheduler and so on. Now, and once this is done, this is what it looks like to the user. To the tenant. If the tenant logs into the dashboard now, this is what his view will be or her view will be. So he or she can see, well, what do I have in terms of HPC resources? I have one GPU node, one fat node, and no generic nodes. And he or she can also see, like, okay, this is my operating system in my cluster, and I'm running a scheduler, that's Slurm. Okay, that's sort of the tenant view. All right, now, that's all well and good, but now you need to run something. I mean, it's an HPC cluster, you want to run an HPC job. So now the PI tells the student, okay, go run make yourself happy, run some jobs. So the student now logs into the login node, okay? And this is just like a regular HPC cluster. You SSH to the login node. For you, for a user, end user, there is no difference. It's exactly the same. You log into this, the VM, the login node VM. It says launch job. This is the batch script, basically. And then from the login node, the jobs get launched on the compute nodes. And the tasks are all running inside containers. So for example, if it's an MPI job, then each task will run in a container, okay? Or multiple tasks can run inside a container. So you can have MPI jobs which span multiple containers. This is what it looks like inside a container. So here, what I've done is, so I don't know if you can see it here. This is the controller node. From here, I've logged into I've SSH to the actual bare metal node where I have containers. And I can do a Docker PS, and you see I'm running only one container. That's just called Trinity. I entered the Trinity container, and these are the processes running there. Supervisor D, there's Slurm and Munge and all that stuff. And it's also running actual compute jobs. So for example, if I do SQ, I can see that there's an OpenFOAM job running here. Well, it shouldn't be running as root. I mean, this is our application specialist running it as root. It's not something you should actually do. You should run it as a user, really. Yeah, and so you see this is a very small cluster. You only have like 2 nodes allocated to it. So you see the point is that this view is exactly as what you would have in a regular cluster. That doesn't change. Okay, so you launch jobs and everyone is happy. So what does Trinity do? I mean, it provides HPC as a service, as I said in my title slide. What it lets you do, if you're a sysadmin, what it lets you do is it lets you partition a cluster into many different virtual clusters. I mean, these virtual clusters are defined by tenant. As I said, each color represents a virtual cluster. Logically, this is a full cluster. Your view is exactly as you would have in a regular HPC cluster. Okay, so it lets the sysadmin partition clusters between, let's say, different departments. I mean, if you can have a virtual cluster for physics, one virtual cluster for biology, or within a department, you can have multiple virtual clusters depending on research groups. If you're a tenant, you can go and request a fully functional HPC cluster. What I didn't show you was the HPC stack, which I probably should have, but for example, you saw that that node was running, that container was running OpenFOAM. So all the required stack for OpenFOAM is already there. It's available through the modules environment, which is on an NFS share, essentially. So you can request a fully functional HPC cluster if you're a tenant. You just go to the sysadmin and say, give me a cluster, and it will happen. And then once you have that, you get the stack, and then you can also customize, because the login node, you can go to the login node, and you can add, if you want to add some extra software, you can customize your environment, you can do whatever you want. You get root access to the login node. And as an end user, what happens? Nothing changes. It's exactly the same. You SSH to a login node, and then you just launch jobs, okay? Maybe through a scheduler. All right, so that's that. As I said, I would keep it very short. If you want, we have, I think we also set up a booth later on during the conference at an exhibition space. If you want, please just come and talk to us, and we'll be very happy to demonstrate it for you. Thank you very much.